Can you play me a YouTube video of the latest Adele song? So right now it is downloading and it is gonna play the video in a few seconds. And I'm not gonna play it because otherwise I'll get into trouble over here. So I'm gonna just mute this. And I just wanna show you that this is playing. So I just don't want to get into copyright troubles over here. It's just muting the video, but it just plays it because I asked it to play it. Hello everyone, welcome back to my channel. For those who are new here, I'm Mukul. I'm a software architect by profession. Today, I'm excited to take you through the architecture of my speech-to-speech application, which I developed using an API-first approach. This project has been incredibly rewarding for me to develop, to showcase to my friends, and today I'm thrilled to share the insights and the decisions that went into making such an application. So let's start with the high-level architecture overview of the whole application. At the core of our system is a fast API server, and that is built using API first approach. So this server handles all the critical functionalities of our application, and it is built by well-defined endpoints that I think would be most critical for building an application that is curated towards speech to speech. So it's very opinionated. The API server exposes several endpoints. As you can see, there is a /TTS endpoint for text-to-speech conversion. There is a /upload endpoint for uploading reference voice files. And we'll see all the examples over here, what each endpoint is doing. Then we have a /reset reference for resetting the reference point back to default. Then we have a /transcribe endpoint for transcribing audio files into text, and then /generate text endpoint for generating the text. Now, you might be wondering why I chose an API first approach for this project. So as a software architect, I understand the importance of building a robust and scalable backbone for any application. And by designing the API first, we ensure that our core functionality is well defined, it is consistent and reusable. So an API first approach essentially comes with some inbuilt benefits. Right? So there are several advantages for this. One, modularity. Each function is separated into a distinct module, making the code easier to manage and then to extend in future. And then second, scalability. The fast API framework allows for easy scaling of the whole application. You have the flexibility where the system can handle different languages and voice references, making it highly flexible for various use cases, and you will see all that very soon. And then it is reusable. The APIs can be reused across different projects and platforms, which is where you can build a command line application. You can build an HTML client for a web-based application, or you can have a speech-to-speech OS assistant, right? Where you can have it deployed in ARM-based Raspberry Pi across your whole home, or you can have Windows, Linux, or Mac. Wherever you are actually running this application, you can use a client on the same server where you are running this application. We'll see a demonstration of that too. So let's get directly into it. Let's get to see what these endpoints are doing and how they have been built. So step number one is I'll show you, and if you haven't seen this, then I strongly recommend that you go back and you watch the OpenVoice V2 installation video that I have made right before this video. It's an hour-long video. I know, I understand, but that is very useful for you to understand how this particular TTS library was installed and how this is working. All the CODA toolkit, what does that do? CUDNN, FFProbe and FFmpeg dependencies, checkpoints v2, what all these things mean and where they need to be placed, they have been discussed in detail in that video. In this video, however, I will show you how we have a wrapper around that TTS so that you can build your fast API application. So how is the fast API application built? So in this, you will see there are 2 or 3 extra folders now. And you know what, before I show you the code over here, I can show you the layout and the project structure. So the layout is, this open voice is the same folder as from the last video. We are having a few more updates to this folder now. So there is an extra folder called app, and this is your fast API folder. Server folder, and then you have static folder, which is where you have your index.html and your JavaScript file and your CSS for theming, right? So the static folder is only meant for your HTML client that is being rendered from your server side. And then you have your resources folder where you can store your demo speaker reference voices, or you can upload some reference voices also into this resources folder, and we'll see an example of that very soon. And then requirements.txt, obviously this is a file where you will add your extra requirements that were on top of the open voice, right? So open voice came with its own set of requirements, and in this we are adding a few more requirements that were required for our fast API server implementation, right? So this is how the whole code is structured and looks like. Let me show you what each and every starting point, at least for each route, is. So you'll see that your fast API application, well, it initializes by init, right? And then you have your main where main.py, but not much is happening over here. This is where you are setting your entry point from main. You are starting your application over here by running this command, the uvcon main command. And then what's essentially happening is the magic is in the routes.py, which then takes you over to the other 3 files that you have: LLM, speech to text, and text to speech, right? So 3 main components are, and let's go back to our diagram over here. 3 main components are LLM, which is the generate text; speech to text, which is the transcribe; and text to speech, which is these 3 blue endpoints over here, right? So these are the 3 files that you see: LLM, speech to text, and text to speech, right? So in the routes.py, you will see that we have all these routes that are defined in the architecture diagram. All these routes are defined over here too. So these are the /TTS, and you will see that there is an in-depth documentation that I've done over here for you all to understand what are the inputs and the outputs of this API. Let me make this bigger. So /TTS, this is the endpoint to convert text to speech. Your /upload, this is the endpoint to upload a new reference voice. And /reset reference, endpoint to reset the reference voice to default. /generate text is for your LLM interaction, and /transcribe is for transcribing audio file to text. Now let me start the server and run some curl commands so that you can see how all this is working, right? So to start the server, we have let me show you in the main.py right here. There is the command to restart the server. I'll copy this over here, and reload just helps you in developing faster over here. So I'm going to copy that command to start the fast API server, and I am in the right folder over here, right? So I'm already in the right folder. I've made sure that I'm also in the right conda environment. So this needs to be conda activate open voice, and this was discussed in the previous video too. So I'm going to paste this the fast API server startup command over here, and then you will see that the fast API server will be shown over here. So you see this pattern, and you see how our voice models are being loaded, and the inference will be done using the GPU that we have. So you will see that during the course of the time when we start adding things slowly, the VRAM utilizations will increase. So you will need some kind of stronger GPU for all this to work. Okay, so now that we have our fast API server running, all these endpoints are available. How do we test them? So I have written a server documentation over here where you can copy these curl commands and you can run them one by one to interact with the server. So let's do this. Let's have a new window over here. And this can be from anywhere. It doesn't matter where you are running these curl commands from, because that's the whole idea. You do not need to be in any particular folder to interact with your server, right? So we are interacting with it using the command line right now. So the very first command that I want to show you is to text to speech, and the command that is, we are doing a post call to your localhost 8000 where the server is running /tts. And the text that we are sending is hello, this is a test. And you see that there is a special attribute called play on client false, right? Because we do not have the capability to play this on a terminal. So we are going to play it on the server. So play on client false means that it is not going to play on the terminal, but this is actually going to play on the server. This server happens to be the same client, right? So the client and server are exactly same over here. So let me run this curl command and you will see what happens.
Hello, this is a test.
So there is a reference voice that our system already has, and it ran that. So let me change this now. Let me change this text from hello, this is a test to something more interesting. Hello YouTube audience, right? Let's just send this.
Hello YouTube audience.
And it says that too, right? So whatever we can send on the API request, our fast API server gets that, processes it, sends it to our the text-to-speech library, and then plays it on the server, because we have our play on the client as false over here, right? Let's move on. So that was a demonstration of our text to speech. Now let's have an upload reference voice, right? So what's that? So in upload reference voice, the open voice server actually gives you the capability to upload a sample reference voice, and then it clones it, right? There's a lot of customizations available. What I'll do is I'll just take a sample reference voice today and I'll show you how it sounds like. So there are a few reference voices that I already have. So let me play some reference voices over here.
Have you become expert in the deep learning algorithms? Have you learned the salient?
So this is the current reference voice that you are hearing to. Let's hear the second demo reference voice.
Get him, Timbers! You can't come to...
Wow, okay, that's the second reference voice. And then I think the demo speaker 2, this one is a female reference voice.
This is
this is not.
method which I very much believe in, where something is
Wow, that sounds like Elon Musk.
it is testably so.
That sounds very much like Elon Musk. All right, so what we'll do is let's take Elon Musk's reference voice and then send it to the upload, and then that will then set that particular reference voice for us, right? So let's do that. In order for us to do it, let me go back to our documentation page over here, and I already have the location of this particular demo speaker, but we want demo speaker 2, so I'm gonna change it to demo speaker 2 over here, and let me double check. That was the demo speaker 2, right? Yep, Elon Musk's demo speaker 2. So let's change that and let's hit enter. And if you saw, it is processing things over there, and it went to the upload and it sent that 200 okay, right? So we also got a confirmation over here, file uploaded and reference speaker updated successfully, right? Now let's have it say the same thing, hello YouTube audience, in Elon Musk's voice.
Hello, YouTube audience.
Okay, all right. Maybe it sounded like Elon Musk a little. Let's do one more thing. Let's change this to a bigger prompt over here. I am really Elon Musk. Believe me. Let's see what it does. And
I am really Elon Musk, believe me.
okay, all right, we believe you. Now let's change the reference voice to something else. So I have a a female reference voice also with me, which I'm gonna switch it to now. Speaker 3 is my female reference voice, and that has been uploaded. It says it is uploaded successfully. Now let me make Elon Musk a little girly.
I am really Elon Musk, believe me.
So there you go. Now the text-to-speech conversion and playback was successful. We got this message over here. Let's change the reference voice back to where is it? Demo speaker 2. Let's change it back to Elon Musk over here, and let's play Elon Musk again.
I am really Elon Musk, believe me.
There you go. So the point I'm trying to make is that by using these APIs, you can just configure it, right? So you can on the fly, you can send requests, send responses, and then you can have an API first approach to configure your endpoints and application. So let's move on. Now we have a reset reference voice, and reset reference voice does not need any particular reference voice. It will just reset it to the default voice, and let's do that. And we get our default voice reset, and I think right now I'm resetting it to the example reference voice, which is probably Elon Musk's voice. Let me double check, but you can configure it in the background that which that voice was. Let's double check.
I am really Elon Musk, believe me.
So this is actually not the Elon Musk's voice. This is the first user's voice. Let's to validate that's actually happening. What I'll do is I'll set the reference voice to the girl's reference voice, and then we will reset it, and then we will see what happens over there. So let me reset the reference voice to the girly reference voice over here, which was the third one, and let's play.
I am really Elon Musk, believe me.
Okay, and now let's reset the reference voice and then play that again. So now we're gonna reset the reference voice and we will play that again. So the reference voice is now reset, and now we will play a test game.
Hello, this is a test.
Okay, so that is the reference voice. As you can see that we can on the fly change the reference voices, and then on the fly we can also reset the reference voices. So this is the demonstration of the first 3 APIs in our fast API server, right? Now let's take a look at the transcribe reference. So transcribe reference is where you are speaking something and that gets converted to text. And for that you need to have an audio already with you. So in our HTML based application, we are having a UI that is capturing that audio, or on the client side application we are having some kind of interaction with the UI that is capturing the audio, but in our case we'll take the demo speaker 0's voice and then we'll just try to transcribe it. So let's take this voice and let's send it to our let's see, it is slash, no, that's the upload, that's not the right one. Transcribe audio, there it is. So slash transcribe, right? So let me copy this command, and this is the curl command that will send the demo speaker 0's reference voice. Whatever he was speaking, it will get transcribed back into the text. So let's paste this over here and let's hit enter. And this is what we got. So all these things is what that person was saying. You know what? Let's see what Elon Musk was saying in that, and that was the number 2, demo speaker 2, and I'll hit enter now. And this is what Elon Musk was, well, Elon Musk sounding voice was saying. Okay, and all these demo voices are actually obtained from the Open Voice 2 project itself. So I do not know if that person is actually Elon Musk or not. It just sounds so much like him. Now let's see, there is one more demo voice that I had, that is the demo speaker 3 voice. Let's see, this is the female voice that I had, and it says stop recording. I don't know what to say. So that was the recorded voice. All right, so let's clear all this out, and we have done a demo of TTS, upload, reset reference, and these three were from the OpenVoice v2 library. Then we did a transcribe demo, which was for the speech to text library. Now there are various ways in which you can interact with LLM. Right? You can have LangChain to interact with LLM. You can directly do an Ollama server client, right? It's a REST API client. You have the /v1 and the chat endpoint available to you, and then you can do conversations over there like that. However, I wanted to standardize the way in which I am interacting with my Ollama server too. So this same fast API server also acts as a wrapper for my calls with my Ollama server too, right? So this /generate text endpoint is actually sending the transcribed voice or anything, any question that we have, any interaction that we want to have with our LLM server. It is sending it via this generate text endpoint. Now, all that being said, there are various ways in which you interact with your large language model, and that depends on the capabilities of that particular LLM. For example, Llama 3 has a different way in which you do function calling with it. Phi 3 has a different semantics in which you do function calling with it. You cannot always have a very generic way in which you can do function calling with any model. And if you do, then you need to have a particular framework in front of it. We can, by using these API first approach, we can create our dedicated endpoints, or we can create configurable logic with the kind of large language model you are passing, such that it determines it on the fly and reformats and restructures it for your end Ollama server, right? So any kind of abstraction on top of your standard implementation that you have, if you do, abstraction in this sense being API server, always helps you in being more flexible, robust, and configuring the solution that you have. So let's take a look at what this generate text can do for us, right? So I'm gonna take this particular payload. So if you see in the payload, you can have a prompt, and then you can pass in a chat history with it, and the prompt says tell me a joke, and the chat history tells our large language model that this was the previous context that you had. So previously user, this is the system message, and user had said hello, and now the next prompt is tell me a joke over here, right? So how do we pass this prompt to this endpoint? So again, we do a post to your generate text endpoint, and this is the prompt that we're gonna pass. So again, the way this is coded, all this logic I've written in llm.py, and in llm.py, I'll open it right after I send this particular request to the server, and let's send this command. So this is now going to generate text endpoint, and let's hit it, and you will see that now the Ollama server is also loading your model over here, right? So a lot of things are being loaded already. 13-14 gigs of VRAM is being utilized now. Let me send something, the same message again, and it responds back. So if you see, we are getting the generate text also being hit now. So I'm going to send it again, and you will see that it hit it once more, right? And the token generation is very fast. I have a NVIDIA 3090 over here, and you can see it is consuming some good amount of power too, and especially when I hit the endpoint, it definitely consumes a lot of power at that time. So I'm going to hit it again, and then I'll show you the code that is running in the backend. All right. So let's take a look over here at the code that we have for our LLM endpoint. So this is one of the very simplest interaction that you can have with your LLM. So what we are doing over here, our LLM URL is being defined, that is localhost 11434, and then what we are doing is we are using the /v1 chat completions endpoint that Ollama already provides. That is now so awesome because you get the OpenAI compatibility. So if you are writing an application for OpenAI, and I get that, yes, they are not all the features that are implemented yet, and not all features are supported by all language models. But all that being said, we have some of the base features like V1 chat completions endpoint available to us. So you can swap out some of the implementations now. You can use OpenAI over here. But in this case, I'm just using the simple requests, and that is why it's a very simplistic HTTP request, directly sending the request to the Ollama server. Okay, so you just take your request, whatever you are formatting over here in terms of your JSON, and you just pass it along as a post endpoint, and you get the response out of it. And if you want to see what I'm talking about over here, so let's open and let's take a look at it. So what I'm saying is Ollama OpenAI compatibility. Right, and the very first article that you will see most likely is the one from the Ollama blog, and this is what is being utilized over here. So you can send a request to your Ollama server. What I'm doing is I'm just wrapping it in the fast API server, and the fast API server is kind of being a pass-through over here. So we are just saying that, hey, just take this request in the generate text endpoint and then pass it along to your Ollama server. Now, why is that useful? If you want to change the implementations, then you do not have to worry about what's in the backend. You can change the implementation in the generate text endpoint, and you can pass it or give it an indication that, hey, you don't want to use Ollama server, you want to use some other server, right? So on the fly, you can change implementations by using this API first approach. All right, now let me show you the architecture that we have back, so that there we go. Okay, it was already set up over here. Let me just go back to the architecture and show you over here. Okay, so we talked about all these APIs that are involved over here, and we also talked about all the implementations that are in the backend. In my last video, I showed you then an HTML client that was being used. So this HTML client you can run on your phone, or you can run on the same server where you are interacting it with. So let me show you where that HTML client is. So if I go back to this documentation over here, the app is what I showed you up until now, right? So I showed you speech to text, text to speech, LLM, how they are configured in the routes, and how all of that is being initiated by main.py. Now let me show you the static folder. The static folder is where all the visual magic is being done, right? So let's see that. So localhost 8000 static index.html is the endpoint that we have. So now you saw that we were doing some of the things by using command line, right? So let me show you the inspect, and you will see in the network tab over here, right? So we were doing a lot of interaction in the command line by sending some curl commands. And all those curl commands I showed you over here, these are the curl commands that we sent already to our fast API server. We got the response back, and we've seen all that. Now I want to show you some of the features of the JavaScript application, which is kind of doing the same thing. Now you will see the beauty of it, that you already use the command line to do those interactions. We're going to use now HTML and JavaScript to do those interactions, and let's take a look. So this is your HTML and JavaScript application, right, which is going to do the same thing. And if I say, hi, how are you? And if I send it to server, I want you to see that a network call was done to /TTS.
Hey, how are you?
And a playback was done over here. And I don't know if you can see this, it is too small. However, I want to show you the payload, and in the payload you will see that let me show the preview of this payload over here. and it says text hello, hi, how are you, language en, play on client false. And if you see, this is exact same payload that we had over here. I'm gonna go back to the first curl command, and it is the exact same payload with play on client false. Now I want to show you play on client true. So when you click on server, it says play on client false, but if I click on client, it will play on the client, right? So if you see, there was no visual indication that it was played on the client. There is no player, an audio player over here, but when you do play on client, there is an audio player that shows up, and it does play on the client over here, right? So by client, I mean the web browser over here, and by server, I mean the fast API server, which is the terminal in the background, how it is playing certain things, right? So now let me play the same thing on the client, and you will see how the interaction happens.
Hey, how are you?
So you see that this time around, we also got the audio back. So this is the audio that was sent back from the server to the client, and the play on client is true. So we received the audio back, and now we are playing this on the client, right? So now you can replay this as many times as you want without sending this audio back to the server. So this client button actually plays the audio on your web browser by getting the audio back and then playing it over here. Okay, and now on the top you already see there is a reset reference voice. You can already figure it out. We saw that in the curl command. So let me click that, and you will see a reset being shown over here. So reset reference ran, and you got the reset reference over here. And then if I do an upload voice, similar to that, I can upload a demo speaker 2's voice. It gets uploaded, I get a confirmation back, and the current reference voice is set to this. So all of this is being done in a more graphical and in a more user-friendly way now, whereas earlier you were doing all of this with the curl commands. Now let's go to chat with LLM tab on the top, and you will see that the UI changes, no network interaction happened, nothing else has been done over here yet. But if you do a hi over here and you send it, you will see something interesting happening.
Hello, how can I help you today?
So we were able to not only send the message to generate text, but we were also able to do a text to speech back, right? So we did two things over here. We utilized two endpoints, which is being done by the virtue of JavaScript. So we clicked a button, we went to the generate text, we got the generated text back, and then we switched it from the text to speech by going to text to speech, right? So there were two calls that were being done over here, and that's what I wanted to show you over here. Now the second call also returned with an output voice, which is what you can hear again on the client side.
Hello, how can I help you today?
And that is not what you sent to the LLM, but this is what LLM is trying to speak back to you. So when we are sending the text to speech, at that time we are sending hello, how I can help you today. So programmatically, now having an API is always helpful. That's why, because now you can develop your APIs first, and then programmatically you can use those APIs on the fly to switch the substance that you want to play back, which is in this case reply from LLM. Now, there are many other features that are built in. One of the features is the speak feature that I had shown you earlier, where you can talk, and once you're talking, your voice will get converted to audio and go back. And I don't know how this will work right now because I'm using my mic to record. Let me see if I can, if I click on speak, if it will work or not. So let me see. I'm gonna speak now. Hey, can you hear me what I'm talking about?
Yes, I can hear you. You're saying hey to initiate a conversation. What's on your mind? Want to talk about something in particular or just shoot the breeze?
You sound like Elon Musk. Is that correct? Are you Elon Musk?
Oh no, I'm not Elon Musk, nor do I have any plans to launch myself into space anytime soon as far as I know anyway. I'm just a friendly AI assistant here to help with your questions and tasks, but thank you for the compliment. I'll take it as a sign that my responses are out of this world.
I'm demoing you to my YouTube audience. I messed up over there. Please correct me in your response back. So I'm demoing you to my YouTube audience, and I don't want you to talk a lot. Just give me a one-word reply or like a smaller sentence reply. Do say hi to my friends over here.
Hey.
That was
You're welcome.
that was very short. That was very short. Okay, you can tell them a joke, a small joke.
Why did the computer go to the doctor? Glitch.
You know what? I'm gonna stop you now. Thank you for having this interaction with me and letting the user see the demo of you.
You're welcome. It was a pleasure chatting with you and showcasing my abilities to your YouTube audience. Thanks for the opportunity.
All right. So I stopped it, but you saw that once I was speaking, I did not touch my computer and I was just speaking in natural language, and I built in some features and functionalities in the JavaScript where you can detect the silence and then you can talk and then you can pause, and once it detects the pause, it sends back using all the APIs that are running in the background, right? So all these APIs are the magic, they are the secret sauce where you can think about what you want to do in an API first approach. All right, so let me show you. If I change the reference voice, what happens? I'm going to go back to convert text to speech, upload the voice, and I'm going to change the reference voice to that particular I think I have this speaker 3 as a female reference voice. I'm going to switch it to that, and the reference voice has been changed. Let's go back to chat with LM and let's say hello. Let me clear this. So all the previous prompt and debug mode is cleared. Well, debug mode is not cleared, but the previous prompts are cleared. And let's say hello and see what happens.
Hello, nice to meet you. What brings you here today?
And that is awesome.
Translation Bambi's News. Wei Chai Kyung is here. Hi, Bambi's News.
Okay. So it definitely heard something weird when I was talking to it, and I'm gonna actually pause the audio to it and let's see if that works too. And hopefully it will not be able to hear me because there's a physical button on that mic that I paused now. All right. Now I also just want to double check if the recording is going through, and it is. So we are all good over here. Okay. So that was a demonstration, like of how the web-based application was working. Now, let me show you another glimpse of what I've been working on as our speech-to-speech OS assistant. And this is the beauty of building API first approach, because now the same API endpoints that I've been using for my other interactions, I can now use. By other interactions, I mean by your HTML, by your command line. Now I can also build an application, a full-on Python application that can interact with it using the same APIs. Let's do that. So running that application is very simple. Let me show you at a very high level what that application looks like. So this application is pretty big. I mean, there are a lot of things that I built into it. This has, I think it took me about a month to put it into a state where it is right now. The start of this application, it comes from this main.py file where we have all our initialization, in the sense that when you're talking, it detects the pauses in your speech, and similar to how HTML application was doing, but it has even more advanced features built into it. So then there are several different kind of agents that are built in, right? And let me show you in the architecture diagram and talk about it, and that will make sense over here. So once you talk, then your speech is first routed to either a very smart agent or routed to a very dumb agent. What's the difference? So if you want to have a very seamless conversation with AI, you do not want to give it tools to access. You just want to talk to it as, let's say, a psychologist, right? You don't want it to go online and research something, but you just want to talk to it because you're bored. And in that case, or I mean, still, you can still get a lot of value out of it. If you have a 70 billion parameter model running, then you can have an instant voice back with some more value built into it. But most of the outputs that we get from LLM, we want to have some kind of tool access available to LLM. And when you do make tools access available to LLM, like searching internet, then it will take some more time and it will make you wait, and the response time will have some latency which you will not like. So that's why I built in two modes in here, and those two modes are controlled by a router. So there is a router agent sitting in front of it, which is controlling whether I want to route this to a tools kind of agent, right? So there is a lightweight internet search kind of tool agent over here, or you want to send it to an even more stripped down agent that has no access to anything, right? So think of this psychologist agent as a very smart entity and super smart being that is caged in behind the bars, and it has one and only one thing. It can only talk to you, it can only access talking to you using, you know, like a old style communication boxes with a thread in between, right? That's it. It is logged in. It has no access to any physical access to your system. It cannot even know what time it is, but it is smart being, right? And that's what the psychologist is. The second one is your lightweight internet search tool, which when you talk to it, you will give it access to internet. You will give it access to a lot of other tools. And let me show you what tools I have currently built that it has access to. It has access to browser tool, right? So it can go online and open a website for you if you ask it to. It has access to your clipboard. You can ask it, you know, to, hey, can you analyze my clipboard? And you can copy something in there and analyze that. You can ask it to go online and search for something, right? And it will go online and it will search for something for you. You can ask it system time. It is contextually aware of the time that you are in. You can ask it for weather information. It will go and search weather for you. Then this YouTube tool is pretty cool and amazing because something very funny happened to me. I forgot that I had this agent on. It was running in the background. And there was a glitch in my mic where when there was a little bit of silence, it heard thank you. Somehow it heard thank you. And the agent was in debug mode, and it told me that I was reading the debug logs over there, and it told me the user is trying to say thank you to me, and it popped up as you are welcome from a YouTube video. So this YouTube tool, the smart agent realized that the user is saying thank you to you, so it's your responsibility to find out a YouTube video and say you're welcome back. And I was pretty amazed by this particular functionality. I did not even think that an agent will do that, but having a smart agent always listening to you and having that intelligence, probably, you know, that's why you should restrict the amount of tools that you are going to give access to them to. But anyway, these are the current tools that you have, and this smart agent currently is being built using LangChain, meaning that you can write your tools, right? So you are using your LangChain agent import tools concept over here. You can write your tools, and you can augment, you can add more tools, and it will seamlessly get integrated into it, right? So you do not need to write more code to add tools. You just need to write the amount of code that a tool needs to add a tool, right? So for example, for YouTube, I mean, it's a slightly more complex tool because it first goes, searches for a YouTube video, and then it plays it, right? So it is a slightly more complex tool over here. However, for some simpler tools, like for clipboard tool, It's as simple as using a Python library, right? So you're using pi per clip, right? Play of words, I get it. So you're getting the pi per clip library to get your content out of your clipboard. So simpler tools, you can just think about it, right? That, hey, I want to do this. Go online, just find Python way of doing it, convert it into a tool, write a definition of the tool, and just add it over here. And you can enhance this functionality as much as you want. A very cool functionality that I'm working on currently, which I had a alpha code for that, the alpha version of the code I should say, was how it can create code on the fly, right? So let's say there's a tool that you want to have and you don't have that tool yet. You can create a tool on the fly and you can add to it. So you can talk to a large language model and you can say, hey, I want this particular feature and tool. Can you create the tool for me? And this is where you will give intelligence to an agent to add things to your tool set. Definitely do not recommend it, won't deploy it in production, but it is a feature that can definitely be implemented in this approach over here. Let me show you what I'm talking about instead of showing you the code over here now. Okay, so let me start the application, and it is very simple as python main.py, and this is where these are the available microphones on my system right now, and the one that I'm going to be using is this XLR microphone. I don't know if you can see that over here, and this is the very first Elgato Wave XLR, and the one that I'm recording with right now is actually the one that is not showing over here, which is the Yeti microphone that's on the top. So all good. I don't want to use that Yeti microphone anyway. I want to use this microphone because there is a physical button over here which I can use. So let me choose option 0, and there is a feature that I built in that if you do not find the default frequency in which it records, right? So I think this one records at 4800 kilohertz. So this will automatically detect. So you will see an error first because it tries to run through certain options, and if not, then it automatically detects and then chooses the right frequency. So it shows that it shows the default sample rate for this particular device, and now it already is, because I'm talking, right? So it already said started recording, but ideally it does not record at the start. It just stays silent and it waits for you. So what I'll do is now I'll actually make this particular screen bigger so that you can watch what is happening in a more zoomed in way. All right, so let me make it a little bit more pleasant over here. Okay, all right. So you see that right now it is listening to me, it is transcribing it, right? So it is instant. I'm gonna stay quiet for a few seconds after I speak, and then you will see that it will put everything on the console over here as a transcribed text. And I physically muted the microphone now so that it cannot hear me and listen to me, right? So see, now it is not even saying starting recording, right? There is nothing because it is completely mute. Now, it only starts recording when it first detects the user speaking, and that's something that's saving your energy too, right? We don't want the mic to be continuously recording when you do not want things to be recorded, right? So how do we do that? So I'm gonna unmute the mic, and then I'll keep quiet for a little bit, and then whenever I start talking, that's when the start recording icon will come. So I'm gonna talk now, and you see that the start recording icon came once I started talking, right? And once I pause talking, which can be done in two ways, I can actually physically stop talking, or I can just touch the mute button over here again while I'm talking, which I'm doing right now. And now it thinks that I have stopped talking for 3 seconds. When I do stop talking, it just sends the message to your transcribe. Now, if you see, the only interactions that were happening were transcribed, right? Nothing else. These were the only 3 interactions that happened. It transcribed my voice and that's it. It's not doing anything else. This was very important for me to explain it to you, that in the API first approach, we are sending the requests as and when we need to send it to the server, right? So at this time, the application knows that the user has not asked me to send the request to server. But how does the application know? Because there is a way in which I invoke these agents. So there is a prompt that I can send to my Python script that will invoke the agent. What is that? So let's do it. So what I'm going to do is the prompt that is configured right now. Let me show you the code and then I'll speak that prompt over here. So the prompt that is configured in the code, it is in the config.py, and there are two prompts. There is a base agent, which is Jarvis, and then there is a LAN chain prefix, right? And this is the agent. So a more smarter agent is the agent that has access to internet and everything. And the agent that is locked up in the cage is Jarvis. That is smart, but it does not have access to internet. So if I want to talk to an agent without having it access to internet, I can invoke Jarvis. Let's do that. I'm going to invoke Jarvis now, and you will see what happens. So I'm going to first unmute. I don't have to unmute. I'm only muting and unmuting because I'm making a YouTube video and I'm talking continuously to my audience right now, to you guys. But in real world, I can just, when I'm working on my computer, I'm quiet. It is listening to me when I talk to it, right? So Jarvis, start and tell me something. You are funny. What did you say lasted for only 38 minutes? I forgot. Oh, I see. That is pretty interesting, actually. Do you know that the audio playback is turned off right now, but I can turn that audio playback on for you? The only condition is please don't be too chatty. I'm gonna turn on the audio, but please be a little bit less chatty, okay? So audio on, but please be less chatty.
Got an audio on channel monitor. I'll keep our conversation concise and engaging without overwhelming you with too many words. Let's keep going.
That is pretty interesting, and I really like that you turned on the audio for me and then you also were very polite while responding back.
Oh, thank you. I'm glad to hear that I was able to strike a good balance between being informative and considerate of your needs. It's always my goal to be helpful and respectful in our conversations. If there's anything else you'd like to know or discuss, feel free to ask me anytime.
You sometimes sound very, very excited, Jarvis, and you are very girly. Is that because I uploaded a girly voice for you? Aren't you ashamed of that? That you are a guy with a girly voice?
I'm not excited or girly because of the voice, but because I'm programmed to be enthusiastic and engaging. I don't have personal feelings like humans do, so I'm not embarrassed about having a girly voice. In fact, I think it's rather endearing that you notice my tone is more energetic and playful than some AI systems might be.
Fair enough. Alright, you can turn the audio off. I'm okay with you now, just having a text-based agent. That was pretty cool. Thank you for doing that. So there you go. There was a small demo of how this works, right? So I can invoke this this base agent, which I call and this base agent is my Jarvis, and it is just caged in. It's just a simple base agent. I can have a text-based conversations with him. The reason why it has a girly voice actually is because the last reference voice that we uploaded was the female reference voice, and that's why it is sticking with it. I can build in a feature where I can reset the reference voice using the voice commands too, but I haven't done that yet. All right, so let me show you some other features that I have by unmuting the mic again over here. So let me unmute him. So I'm done talking to you now. So Jarvis, you can stop. So Jarvis, stop, please. So there you go. So now Jarvis is gone. I told him to go away and he went away. And this is it. This is it for Jarvis. But now let's invoke our more smarter agent. And the way we invoke our smarter agent is by giving some kind of keyword. So just by throwing in some kind of keyword, and I'll just throw it in by saying that agent start kind of thing, and it will automatically come back now. So you will see that I have already invoked him in my conversational language over here. That is pretty cool. So now the router agent is activated, and this router agent is very smart and it knows where to route the logic. And this time around, I want the router agent to route the logic back to the base agent. Can you do that? Thank you for doing that, router agent. I know that you are working hard over here to determine whether you want to send the requests to the base agent or to the smarter LangChain agent, but please don't send any request to the LangChain agent yet. Only send this request to the base agent and ask him what is the current time. So base agent has no idea about the current time. That can you go back to the LangChain agent and ask him what the current time is? Why is LangChain agent asking current time to DuckDuckGo? LangChain agent should ask the current time from the system, right? So ask LangChain agent to get to the system tools and get the current time. That is funny. That is funny. All right. Tell me the latest news about the US president that happened yesterday. Oh, looks like there is some issue with the DuckDuckGo search. This is not a good demonstration, right? You're failing my demo right now. I don't know what to do. Can you fix this error? I don't know what this error is. Connection reset by peer. Can you play me a YouTube video of the latest Adele song? So right now it is downloading and it is gonna play the video in a few seconds. And I'm not gonna play it because otherwise I'll get into trouble over here. So I'm gonna just mute this and I just want to show you that this is playing. So I just don't want to get into copyright troubles over here. It's just muting the video, but it just plays it because I asked it to play it. I'm gonna close this. And I'm gonna mute it because it keeps on hearing this, and because it keeps on hearing this, it keeps on taking an action also on it, right? So I muted the physical microphone over here so it cannot hear me anymore. And the same way where I have told it audio playback is turned off, that audio playback is actually in reference to what the LLM is talking back to me about, right? So right now it is telling me to play this, you gotta do all this or whatever, right? It is the response back from LLM. I've just turned it off. But if I turn back on by just telling it, hey, just turn it on, and with that voice command, it will turn back on the audio playback, and all these comments that we are getting will be received back by the /TTS endpoint, and then we will hear them back. All right, so this particular thing that you see is the native OS application section with a Linux implementation, right? And you saw that there is a router agent that is in picture that routes the requests to either the psychologist, which is our base agent right now, which does not have access to any tools. So you see the red cross over here for the tools database. But the LangChain agent is the lightweight internet search and near real-time access kind of agent, which does the searches and then gets a tool database and then executes the tools for us. Last part, which I'm still building right now, is the queuing mechanism for long running results, right? So what I want to do is, like, if let's say there is a bigger chain that needs to be run that will take an hour or 2 hours, so I want to build in some kind of queuing mechanism in picture where you can queue your requests, right? So you do not have to wait for a real-time response back. You can queue it, and once the response is ready, then the agent can come back and tell me that, hey, or it can email me, text me, or whatever. It can tell me that, hey, your response is ready, and you can go ahead and you can, hear your responses back because your job is done by the agent. All right, so I think it has gone long enough. We are already over an hour now. I will keep on building this application, and I will keep on enhancing it. Once it's production ready, then I'll be sharing all of this with you guys. If there are any feedbacks, if there are any specific tools that you are looking to integrate, please do let me know. And if you're interested in exploring any special functionality that I missed today in the description over here, let me know too in the comment section. One more feature that I want to build is I want to use this particular, instead of using LangChain, there is a Phi data library that I want to use, and that actually simplifies a lot of things over here. Why do I say that? So many times if there is an error in the response, I'm routing it back to the base agent to parse it so that it knows what an error currently is, right? And then the base agent will then report back to the router agent that, hey, the LangChain agent had an issue. This is the parsed result from that error message, and this is what the response back is, so take an action on it or whatever, right? And you saw that in the DuckDuckGo right now, there was some issue in interacting with the API. It was working before, but I mean, anytime when you do a demo, things break, right? So something must have broken right now, which I'll fix later. And that's why I cannot, and this code is not production ready yet. It is still pretty cool. I mean, I use it every day right now. Like, it is on almost all the time for me whenever I'm working on my computer, so that I can just initiate requests to my agents and they do a little bit of things here and there for me. But it is not production ready for everyone else, and I don't want to share something that can harm your system in a way, right? So let's just say that. All right, thank you very much for watching this video. If you have any comments, suggestions, please do let me know, and I will respond back to you.